but presence is where people in virtual or mixed reality tend to respond to virtual events as if they're real.
And complex human behavior such as communication and social interaction. So I see the practical activities of building the space such as XIM.
So these three areas, as I will explain next, they are very tightly related. There are some specific neurons in the brain which are the ones under...
The same as visually you can talk about your virtual body as an avatar, you would think about the sounds produced by your body in the virtual environment as a sonic avatar.
Objective based on analysis of physiological data. The real killer application, something that you really cannot do in any other way, is this transformation of the body that I've been talking about. There's no other media I know that you can look down and see your body as something completely different. For example, you look down and your body is the body of a dog.
It's making photos of people while he explores the environment. He's leaving them on the playground. And in fact, its behavior is based on several internal variables like security or arousal, curiosity, energy, and he tries to equilibrate them with the environment.
Can you sense other like objects that are in front of it?
It could, but it's not the purpose. The purpose was to do like a virtual arena for robots, and just use them as a learning tool for investigating about algorithms that could learn with dynamic cues.
So how are these programmed? They've got like AI and you sort of teach them and...
in fact, it's a very simple... right now it's a very simple algorithm.
Laika suposa que és com un robot que tinc de 3 anys. O sigui, encara no és un robot autònom, necessita que algú s'encarregui d'edició. Bueno, sí, què el sents?
No pot menjar.
Exacte, no pot menjar. Per què no pot menjar? Altres que vaig.
Preview of the devastating forces of our future. Unsuspected revelations of incredible horrors that will terrify you with their brutal reality.
Not
Human, not Cylon. Friends. We are the robots. We are the robots. We are the robots. The robots.
That's also what we then do in the synthetic foraging project by developing novel integrated experimental environments.
Because
That's basically measuring the heart rate. You can predict if the animal is going to do good or bad trials. We do another part of experiment where the physiology.
These two subsystems are bring to equilibrium separately and then integrated to finally generate as a correlate of one of the subsystems driving the artificial rat. This line is the plot on real time of the arousal felt by the robot. When we see the arena, color of red indicates a maximum arousal. So here we see two subsystems interact.
Everything. This tetrode is slightly too deep, so it's going more towards the fissure. There you have a lot of big dead acting.
So what's happening here, the robot is exploring the environment, learning the world, let's say, building the representation.
Here we have an example of the representation of grid cells. And here we have a readout
all the modeling efforts to explain rat foraging in the robot.
Now we have the DAC architecture, and we want to validate it against the rodent brain. You cannot do that in one step. This has to be done in a very systematic way, looking at different subcomponents. Let's focus on the issue of memory. DAC assumes that there's a short-term memory buffer that constructs representations of behavioral episodes, which are used for future reference in planning. This is the role of the hippocampus, we believe. So let's take this assumption and go back to the hippocampus in the rat brain and pose the question, what are the boundaries of these episodic representations? Does the rat only represent static space, or can I also represent dynamic space? Can I represent the properties of other agents in my environment? So for that, we're going to use the integrated experimental environment we built in the SF project, including the so-called smart object, to look at, in a very controlled way, how rats represent dynamic environments.
And we want to have a look and see if there is a representation of the robot in the hippocampus of the rat. So see if he uses his place cell system to see where the robot is on the maze.